Python Live series, powered by the Live series and Amicus Recruitment. For those of you who don't know who Amicus Recruitment are, we are a specialist IT recruitment agency that focus on 3 key areas of IT, which include Python, Golang, and JavaScript. Now, my name's Jordan Hayward, and I'll be your host today. I specialize in recruiting across the Python market, specifically within Austin, and also remote opportunities across the US as well. Now, today I'm joined by Josh. Josh is a product manager over at the Kubeflow community, and he'll be giving us a brilliant update on and demo of Kubeflow 1.6 ahead of its release. Now, as ever, there is a Q&A tab at the bottom of your screen. So if you do have any questions, please do pop them in there, and myself and Josh will get to them throughout the course of the session. But yeah, that's enough from me. Josh, I'm going to hand over to yourself to kickstart. Thanks for joining us.
Hey, and thanks everybody for making time. And Jordan, thanks for the opportunity to say hello to the community and provide an update on Kubeflow. It's something that hopefully you can hear me okay. Something in Kubeflow as a community and as a project, a software project that I've been passionate about for several years now. And so one of the things that I did 4 or 5 years ago was join the community and then start to volunteer as a product manager for the community, which really helps to bring out and new releases. So I'm going to talk about some of the process and how we got around the new release. But again, my name is Josh Bottum, and I'm a Kubeflow community product manager. And this we're going to do, as Jordan said, kind of a combination of a few slides, 10, 15 slides, and then we'll go in and do some demonstrations. So about 50-50 on the time. Probably take about 35 minutes. We're going to talk about why market leaders are building their ML platform, because that's what Kubeflow does. It's an ML platform, an open source ML platform on Kubeflow. And then talk about the user survey results. We run a user survey. I think it's important for a community to listen to the users. Talk about how Kubeflow streamlines some ML workflows and simplifies operations, do some 1.6 update and demo, and then how do you get involved in the community. One of the things I like to start with is why even consider Kubeflow, right, as a place to invest your time. And you know, when I sat back, whatever, 4 or 5 years ago, whatever it was, and looked at the open source projects, if you look at GitHub, there's maybe 50 million projects out there. But if you look at the major open source projects, you'll always see 2 that kind of filter up to the top. One of them is Kubernetes, and the other is TensorFlow. And one of the things that I really liked about joining in on the community and investing time in this is that I saw that basically, if I was going to be in machine learning, what Kubeflow originally did was be able to take machine learning and run it on Kubernetes. And so here you've got a lot of momentum of these projects that are in the top 10 of all the GitHub projects, most forks, most stars, most contributors in most cases, you know, in a lot of ways. And you've got Google basically open sourcing this technology and then putting it out into the wild and having people then extend it. Before Kubeflow, basically what we saw with building an ML platform is that you had a lot of tools and communities, and they were very good. You know, there's many of them out there, but often if you're trying to do an end-to-end workflow, it took months of analysis and integration. You had to build, test, and document your support practices. And then when you got it all together, you had some custom forks and limited portability. On the Kubeflow side, I think from an architectural standpoint, you started with a Kubernetes native ML platform and a tool set for integrating end-to-end workflows. And we'll talk about this as we go through. But this portability that's provided both from the Kubernetes allows you to move between clouds, whether it's Amazon to Google or Azure or on-prem. But the other thing is, a lot of times you're just moving from your own environment, from dev to test to prod, right, to production. So you need to be able to move a lot of dependencies and code and other requirements basically between different environments. And what you really get, and I hope will stress throughout this, is that all of this is built upon a Kubernetes platform, which gives you some efficiencies that fit very well into machine learning. The idea is Kubeflow is going to help you build more models and have better business results. And really, I think what it really comes down to is the architecture helps reduce the ML operational sprawl. And what I really like about it is this broad community that shares best practices. So when you start to look at these type of end-to-end workflows, everything from building a model, which in Kubeflow, we'll start with a notebook, and on that notebook, you could run Jupyter Notebook, or you could have RStudio or VS Code. But what's nice here, again, with Kubernetes is these get isolated into namespaces, so they can have resource quotas, and people can be running in their own space, or they could share it with others, right? So you can have isolated, or you can have shareable namespaces, but you've got that nice Jupyter Notebook, which is iterative way to do and get instant results as you're trying to run different cells in the notebook, if you guys are familiar with that. And then in training, when you train your model, one of the important things is, or potentially for some people, is going to be able to scale out that training and be able to scale it out on different types of resources. So you may want to scale it out on GPUs or CPUs, and you may want to be able to use different types of frameworks. So you may want XGBoost or MXNet or PyTorch or TensorFlow. What Kubeflow does is give you an API that's a single API to be able to run all of those. So you have a very consistent operational behavior, but you have this way to scale up and then scale back in after your training job is done, saving you time, saving you resource costs as well. And then having hyperparameter optimization. So after you've trained your model, those are just the parameters inside the model. Often there's a lot of other parameters you have to optimize: learning rate, epochs, batch size, you can go down the list. But in order to do that search space, often people are using hunt and peck, basically a piece of paper saying, okay, now I'm going to change the learning rate a little bit, or I'm going to change the epochs or whatever. Instead, Kubeflow gives you a tool to be able to do that. And an example of this is we were at the Kubeflow Summit a couple of years ago, and they brought a Kaggle model that had won $1 million, and they ran it through the hyperparameter tuner one time, and they improved the accuracy of that model by 10%. I'm not saying that that's going to happen all the time, but it was kind of an interesting demonstration that they did. Also, Kubeflow supports something called AutoML. AutoML being basically you just give the system a data set, and it's going to tell you which one of the frameworks is probably best suited in order to use, so you can then build your model on top of that. So maybe it's TensorFlow, maybe it's MXNet, maybe it's XGBoost, but maybe you don't have the time, or maybe you're too to go check out all those different options. AutoML does that for you. It also includes an analysis tool, so you can visualize your data in three-dimensional space, as well as your models, and that's called TensorBoard. And for those of you that have used it, we provided tools to make TensorBoard easier to use and display that. Probably the most widely used component of Kubeflow is the ML pipelines part, Kubeflow pipelines. And that allows you to have step-by-step process that has containerized environment for each of the steps along the way: load data, pre-processed data, model training, model evaluation. And each of those steps in your workflow can have retry mechanisms, and it can also be running on different infrastructure. And again, with Kubernetes, you can put labels on what each of those steps need and run them on different types of infrastructure. So one may need a lot of memory, another may need GPUs, right? But that's automatically allocated. And then inside of Kubeflow, another step along the way is your metadata tracking. There's a lot of, besides just your model parameters, you also have a lot of other metadata that you need to track, and Kubeflow gives you a way to do that. We'll go in and show a little bit of that. And then the deployment, when you go in and you're ready to start to do prediction, Kubeflow has integrated with it a component which now has broken off and become its own project, but it's still very tightly integrated with Kubeflow. It's called Kserve. And in Kubeflow, each of these components can be used independently or as a complete system. But Kserve in particular, what's nice about it is that you can have, as you're trying to integrate into, let's say, these REST APIs into your application, it allows you to have a pre-processor, a predictor, and a post-processor. So maybe your data isn't coming in exactly as you want it. You need to pre-process it. Maybe that needs to be, again, on a certain type of node with GPU. And then you have a prediction phase. That's handed off to another pod that basically could be running on a different node, and maybe it only needs CPUs. And then maybe there's some post-processing before you hand it back to your application. But the idea here is that you've got this very flexible way with all the networking engaged to allocate those pods and be able to scale them up and scale them down. So that's probably the longest slide that I'll go through. I know there was a lot of detail there and I went relatively fast. It'll be better when we get into the demonstration. Kubeflow users, right? We've seen really first-class type of organizations, whether it's LinkedIn, Spotify, Gojek, Intuit, come and talk to the community. I mean, LinkedIn talked about doubling the effectiveness of their ML engineers. Spotify, teams producing 7 times more experiments. Gojek, 100 million ride-hailing booking jobs monthly. And then Intuit using Kubeflow for production products that they have for advanced orchestration and experimentation. And all of them have written these blog posts or done presentations. Those links work. One of the things I started a few years ago as the Kubeflow product manager, I have a lot of responsibilities. One of them is allocate, triaging GitHub issues or whatever. But this one was, we needed to get feedback from end users. So we started a Kubeflow User Survey. And here's some survey results from the 2022 user survey. This shows you, the ML engineers are the prevalent folks that at least speak up in the user survey, and then architects and data scientists. After that, there's just a host of engineers that come in and talk to us, with data engineers, DevOps engineers, engineering managers, Kubernetes platform engineers, and software engineers. We see some executives and product managers coming in and more over time. I added this in here because I thought it'd be interesting to see which ML frameworks people use. And this has been traditional through the years. TensorFlow tends to be the most used, with Scikit and PyTorch often being very kind of close up here as well. Keras and other products like MLflow being integrated, or Airflow, XGBoost. So you see that there's a host of different types of frameworks and tools that people are using. But I thought that was kind of an interesting. One of the things that Kubeflow really works to do is to help you build models faster. And so what we've noticed from the community is that 50% of the models are replaced within 3 months. So if you look here, some of the models are replaced within a week, some are replaced within a month, and some are within 3 months. But about 50% are replaced within 3 months, right? And then if you look at the model versioning, 17% of the models have less than 5 iterations. But that means that, whatever that is, 83% have more than 5 iterations. So, you just do the math. If you have 10 models and you're having to do 15 iterations per model and you're replacing those every 90 days, you've got a lot of things that you need to track. And that's one of the things that Kubeflow helps you to be able to do. Now, as a product manager, I'm very, I don't know, maybe defensive, but I try to keep an open mind. And so I always ask these questions like, what are the biggest gaps in Kubeflow? Because we need to know where we need to work on. So one of the things is documentation. So, I don't think this is a surprise to anybody that's worked in open source. They know that documentation needs to be improved, as well as tutorials in installation and support and security. What I would say on all of these things is that there is a community of distribution providers, we'll talk about those later, and support organizations that do provide those type of support for you. So there is the open source for free type of things. This is a very complex environment. I'm not going to say that it isn't. You've got a large stack when you look at it, and often you're going to need support beyond unless your team is a Kubernetes native organization, you are going to need some help with getting Kubeflow up and running. Now, the idea here around Kubeflow is we want to have releases, and the purpose of the release is to improve the user productivity through the introduction of new functionality that simplifies operations and streamlines ML workflows. And basically, the way that we do this is we have a group of users, right? They're providing input to us through Git or on our Slack channels or even through email. And then we have working groups, and the working groups are developing the code, right? So these are the different organizations, the notebook organization, the training group, the Kubeflow pipelines, the serving. And then we have distributions. So the distributions are the companies that support this in production. So Amazon or Google or IBM, you go down to Nutanix, Cisco. And basically what we do as the release team is we try to bring the users together with the working groups, come up with a schedule, and then have the distributions after everything is put together and ready to test, have the distributions test it and document it and support it for the end users. You can join in the community in a lot of different ways. There's community meetings, there's GitHub tracking of the issues, there's Slack questions that you can answer and ask, as well as there's a mailing list on here. To talk about 1.6, basically to give you a kind of a view of how this kind of is coming together. 1.6 is due in September. September 7th is currently the date that we have. We track everything on milestones and timelines. We have Kanban boards. There's installation docs and code that are available. All these click-throughs work. And then we have roadmaps from each of the organizations. So the training operators, Kserve, Cattib is the hyperparameter tuner, as well as Kubeflow pipelines, notebooks, and just Kubeflow in general. All of them have roadmaps that we keep up to date. So even though we have something called 1.6, which is overall for the whole project, each of these individual projects have their own releases too. And so this one could be 1.6 for notebooks, but Kserve could be running on 0.8 and Cattib could be running on 0.114, right? So this gives you an idea of all the work that we put together to get basically just the general code together. Then it's handed off to the distributions. So these are all the distributions that are supported in Kubeflow, and this getting started page is probably a good place if you're looking to get started with Kubeflow. But you can see we have Amazon and Azure and Google and IBM and Nutanix, OpenShift for those who run it on-prem, probably interested, Aricto and Canonical with their Charmed. And we'll see Oracle add in on 1.6 as well. 1.6 on highlights, right? Basically, we're upgrading, for those of you who are Kubernetes savvy, the ability to support Kubernetes 1.22 and a preview of Kubeflow Pipelines 2.0. 2.0 provides a new architecture with a new DAG and an improved pipeline authoring experience. Now, all the V1 experience is supported, so you don't have to worry. If you're using V1, all the legacy capabilities are there. But if you want to start to use V2, because there are some advantages, There are some breaking changes between V1 and V2. If you're starting now, V2 is just starting to be in beta, but I think it's pretty mature. And I don't know if you're not ready to go into production yet, you may want to start here. But if you're in production, you may want to start on V1. The training operator in CATIB, you've got a new hyperparameter support for population-based algorithm. And then you also have a new Python SDK for PyTorch, MXNet, MPI, and XGBoost. The notebooks, we're going to show objects for all the namespaces. This is also extended into the central dashboard, the volume manager, and TensorBoard. These things will become more relevant as I start to show the demo, and create separate workflow for each notebook server. In the operational improvements, we'll fix some CVEs in the central dashboard and provide a profile controller and webhooks, and also provide for a controller gen for the pod defaults. And then in the model serving, there's a new cluster serving runtime and a serve time running CRDs, custom resource definitions. These are basically extensions to Kubernetes that allow you to have very efficient operational, and a new model spec that was introduced that allows for inference service prediction spec. And this will make it easier on the end users as well. And for those of you that are really trying to figure out, what do I need to get started with inside of Kubeflow? These are some of the projects that you'll need to have experience with. Kubernetes, Istio being the service mesh, gives you security between the applications as they're talking. Knative as well for scaling. Cert Manager, so authentication, authorization, very important. Dext for being able to do integration with your single sign-on, as well as customize for the deployment pattern, which uses manifest to deploy all the software in the proper format. So I know I covered a lot of stuff there. Hopefully for you that are in the Kubernetes space, some of that was relevant. I'm going to jump into a demonstration now, but maybe before I do that, Jordan, I'll stop and see if there are any questions.
No questions as of yet. We did just have a general comment though, saying the biggest obstacle for me to try Kubeflow is that it doesn't have a Helm chart. Helm charts are basically a gold standard nowadays. It's simple to understand and maintain for the user. Please consider providing an official Helm chart, which I can send through to you after, Josh, just so you can take that on board.
Yeah. So 3 or 4 years ago, we had a big discussion about the installation pattern for Kubeflow. And there was a discussion about using Helm. And I think back then, Helm was still being improved. There was a second part with the Helm that was going on. But the other part was, when we looked at the simplification of all the software and all the different layers that you needed to do, manifest with customize, just won out in the community. Now, there have been people who have tried to develop and have developed Helm charts periodically for deploying Kubeflow. And there is some of the feedback that we got, at least 25% of the community asked, can we bring the Helm chart in and start to, but understand that this is probably not an XXL, extra large feature request, because we've already have one installation pattern, and then we'd have to go to Helm. I'm not opposed to it. In fact, I'd like it. I just need more folks to contribute to be able to support that, because there's a lot of testing and documentation that will come. There is a group that is actively looking at it. And if you want to get involved with the Helm chart, I really encourage you to do that, because I think there is, as stated in the question, kind of inherently, it is a very popular thing. And I think it would make things, it would make adoption easier for a lot of people who are Helm based. But I wanted to give you that background that, we spent a lot of time looking at it. Now, I would say that if you go to any of the distributions and you ask them to help you with the installation pattern, I think you'll find that the installation pattern, we've got it down to one line in some instances. But look, I'm not going to make it easy. you've got to worry about networking, storage, authentication, authorization, integration with single sign-on, doing GPUs and CPUs. There's a lot there, right? And you really do need somebody who's a platform specialist, either on your team or external, or maybe both, in order to make sure that you're setting up all those components correctly and be able to scale up and scale down. What I am going to do, hopefully I over answered that question, but it's a little joke. Hopefully you're getting a little feel for where we're at. I am showing a distributions view of central dashboard of Kubeflow. And in this is from Aricta, which is a company I kind of helped in their early stages for the last few years. I don't work there anymore, but they've modified this a little bit. So your typical Kubeflow isn't going to look exactly like this. This is a very easy way. If you haven't used Kubeflow before, you can go into GCP or AWS, and they have two different ways to get started. One of them is called MiniKF. And for, I think it's 55 cents a minute, an hour, 55 cents an hour, you can go in and run and bring this up. It takes you maybe 12 minutes to bring up a full Kubeflow cluster of the 40 pods. And then from there, they give you a lot of tutorials that you can run through. And I'm going to run through one of the demonstration of some of the tutorials. So I'm not going to go through the whole tutorial. I'm just going to give you a flavor of what all the things are. So anyway, this is kind of the picture of the central dashboard from Aricta's version of MiniKF. I like their Kubeflow as a service offer a little better. It's free, and you can get a good flavor of what's going on using that. That's the place I would start if you haven't ever used Kubeflow before. But what on the central dashboard, what I do want to highlight is usually you have a login screen. I've already logged in, but you have user credentials that you put in. After you do that, you are then put into a profile and a name, and then you can pick the namespaces that you want to be in. Now, what's important about having a namespace, and I could have multiple namespaces here, one for me that I only use alone, or one that's shared among all the ML engineers or all the data scientists, or maybe just on a project. But what's nice about this is that you have isolation between users, and you also have resource allocation, right? So you can protect quotas and those type of things based upon this particular. Now on the Kubeflow, and I'm showing the UI here, there's a UI, there's a CLI, and then there's SDKs, right? But right now, what I'm going to work from is just the UI to make the simplified kind of end-to-end workflow. We're going to start from a notebook. We're going to build a pipeline, and then we're going to show that model being how it looks in production. And hopefully for all of you that have done live demos, you can appreciate, you know, the live demo God is on my back here. So, or with me. But you can see you have notebooks, and I'll click into a few of these things. This is what the notebook server looks like. We'll go in and show how to configure a notebook. So this is first just showing all the notebooks that I have running, right? The status that they're up. This is a notebook. I have a couple for dev and two that I'm using for serving. The type, these are all Jupyter notebooks, how long, last activity, what image they're running. Since these are all running on Docker images, you can basically set an image that has, and we'll talk about this with all the dependencies in it, whether it's GPUs, CPUs, what memory, what the volumes are there, and how to connect into it, how to stop it or delete it. Now, if I want to go in and create a new notebook, this is really nice for an end user because they can come in and give it a name like demo, right? And then put it into a namespace. They can put it into a share namespace of their own. You have your Jupyter, you can pick it as a Jupyter notebook, a VS Code, or an RStudio. And then you have images that you can pick from, right? Now, these, as you can see, some of them are for PyTorch, some of them are for Jupyter or SciPy, some of them are for TensorFlow with GPUs. But you can also have custom images that you build and that you can pull from your own repo from here, right? So you can just define where you want to pull your image from. You get to set your CPU and your RAM. So this is really cool, right? As well as your GPUs. You can set your workspace volume. So you give your volume a name, how much data you need, you know, what's the size of this, what type of class it is it read-write or read-write only? a read-only mini or read-write mini, right? So you have that option. You also have data volume. So you have a workspace volume, and then you could have lots of data volumes that you attach into a notebook. You can set configurations as well as affinities. Affinities are kind of nice because, look, you may not want to run a small notebook on a GPU-based node, right? Because GPU-based nodes are expensive. So you'd want it to put a label on it that says, don't put it on a GPU-based node because I just want it to go on a CPU-based node. And then you hit launch. And when you hit launch, basically you're going to get a notebook. This is a notebook that I'm creating here, which is for an example that that you'll see from Aricto. You don't have to use theirs. There's plenty from other distributions. Typically, it looks like this when you first come into a notebook, and then you'll go in and use this terminal to pull in, to wget in, you know, your data, all the examples that you want to run. Those are all over here, right? You can see I've already fetched all this stuff, and I already have these examples downloaded, and I have all these notebooks that are available to me. I'm in Open Vaccine. I've opened this one up. This is on COVID. It's an mRNA vaccine degradation prediction model. And basically what we're doing in this model is that we're trying to figure out which of these bases of this mRNA molecule are best to build our vaccine on, which of these bases are prone to cut, what's your safe from degradation. Obviously, we probably want safe from degradation because we want our vaccine to last longer. I would say that, this is just an example of what you'll do. So there's some very advanced, and one of the cool things about working with the Kubeflow community is they're solving really cool problems, right, all over the world. But in any, type of software development, probably what you want to do is have groupings of different things that you're doing. And first thing you typically do is install some packages, right? And you're preparing your environment and doing some imports, like you're bringing in pandas. So up here, when you're doing you're bringing in packages, it may be TensorBoard, it may be TensorFlow or other things, the latest versions. But in imports, you might be doing things like pandas or NumPy and giving them easy names to remember. I'm going to come back to this project on the hyperparameters, but it is important that you do set the hyperparameters. But really, the first part of our model we're getting to is our load data step, right? And basically what we want to do is fetch our data, bring it in. And then the second part of our project is going to be pre-process our data. And in this, notebook, basically each of these cells are individually runs steps inside of our processing that we can use and run using this little run statement, and we can run any of these individual cells and get results back. So that's why this makes it very nice to do an iterative and experimental. I don't have to run a long program. I can just run little steps at a time and see how they give me results. But I'm pre-processing data here. And so I'm using a tokenizer as well. We'll come back to that when we're serving. But now we get into doing some of the pre-processing of the features, doing some process labels. Then we get into training the model, right? And finally, we get into evaluating and submitting the model. Now, what we want to be able to do eventually, once we have this model in a place where we're getting good results on it, is to move into more of a pipeline-based environment, because we may want to run this model every day, right, at a certain time. So we want to load our data, pre-process our data, do some model training, model evaluation. We want to do that every day and have a system to do that, a workflow. And that's what Kubeflow pipelines do. And they give you containerized steps that will support all of this. So each of these are containerized steps. So how did I get from this notebook over to the pipeline? Well, there's a lot of ways to do that, but one of them is that I can manually decorate the code and then compile it. Another way to do it, and that's all done through what's called Kubeflow Pipelines domain-specific language, and using those tools is to use this tool called Kale. And this is a tool that was developed by Aricto. And what Kale does, and you can see I just turned this on, it's an extension to a Jupyter notebook. It allows me to do certain things, but one of them is to label steps in my notebook. So if I use this little icon right here, it allows me to pick what these cells are within the notebook. And in this case, I'm labeling this one as a pipeline step. I'm giving it a name, load data, and saying what it depends upon. This is my first step in my pipeline, right? So it doesn't depend and whether it needs GPUs or not. Now, after I've labeled this, basically all of the code that comes behind this now is going to be included automatically in a container that is automatically built for me called load data when I hit this compile and run button. So I don't have to do any work to compile and run or create that pipeline, because basically I'm going to go through all of my steps here. Like I do the same thing for pre-processed data, right? I go through and on pre-processed data, I just go in and I say, hey, this is my next pipeline step. It's called pre-processed data, and it depends on load data. So I can pick what it depends upon. And now I start to get that sequential action that I wanted, which load data then goes into pre-processed data. And then the next step being model training. Again, I just go in on the little icon over here. I say it's a pipeline step. I give it a name, model training, and then I have pre-processed data as being the step before it. And then the final step here is model evaluation. Now, I just hit this click and run, and I'll do this, and it will start to go through, validate the notebook, take a snapshot. This is integrated with some things Aricto does in terms of snapshotting, but the concept here is that it's going to build the pipeline and then submit it. So you'll see this start to upload and then view and run the pipeline. And if I go in and click on this right here, you'll see that it'll start to build that pipeline that I showed you before, right? It first starts and it uses a lot of persistent volumes. For those of you that are familiar with Kubernetes, you know that that construct is the way that you have persistent volume, is using a Kubernetes persistent volume. And that's a great way to start, because you can put your data in there and you can put your code and all your dependencies. And now you have a great way to come back and pick it up as you're going down the way. Now, you're starting to see it's doing the load data. I've done this over here. I've got load data, pre-processed data, model training, model evaluation. This is the one that's been built out already. But you'll see this starting to build out as we've done that. Now, once I have this pipeline built, the next step that I want to do is I want to be able to go in and do some hyperparameter tuning. That's this part right here. So if I click into the hyperparameter tuner, right, this is what the hyperparameter looks like. It's going to give me results of, I need to be able to check, how do I set the dropouts, the dimensions, the batch size, the learning rate, in order to minimize validation loss. And this is kind of a representation of some of the trials that I've run, right? And you can see all the trials that I've run right here, but I don't want to do that manually. So another thing that Kale enables me to do is I can set up my hyperparameter search space right here. And so I've turned that on, and in order to use it, I have to do two things. One, I have to go and tell what I want to optimize on. In this case, I'm optimizing on validation loss. And again, I'm using Kale to say that I want a pipeline metric that I want to be able to do some optimization on. So this little tag here helps me. The second thing is that I've set up all these pipeline parameters, right? So this is the second thing that I've set up that I told you that we'd come back to. These are all the pipeline parameters. And again, I've got my learning rate, my epochs, my batch size, all those things. But now I want to do a search space. So I can go in to my cat tip job, and through this very nice UI, I can set my learning rate and have a min and a max and what the step is, and do this as a range or a list. And I can do the same thing for epochs, the batch size, and dimensions. You can see this could become a very large search space if I've got multiple parameters, got my dropouts, right? All these different things. And then I have different ways to search: random, grid, Bayesian. Again, I could have multiple search objectives. This one just has a validation loss I'm trying to minimize on it. And then I can do my run parameters. I can run things in parallel. I can say what my maximum trial count is and when I want to, if I have failures, when I want to fail. But once I hit this and say run, eventually it's going to run all of these and bring this out. Here, let me make sure I get the right tab. And it will start to show all these different search space trials that I've tried. Here's what it looks like in the graph, and here's what it looks like in the and you can see this is interactive, right? Sorry, my screen isn't big enough to show you all of this in one space. But the idea here is I want to get to the place where I've optimized, I've optimized my validation loss at the lowest validation loss, because I've got the best learning rate, the best batch size, and the dimensions and the dropouts that I can find. And this is what that CatTib tool does. So then once I have that, I can go in on this little parameter here, and this brings a lot of detail in. And I didn't go into a lot of the detail before, but I can look at the model evaluation step and I can see all the inputs and outputs. So each of these steps have inputs and outputs, and they have, you know, what their basic container and other things that they were using. But you have visualizations. So in this case, what Aricto does is they take a snapshot of that environment, which means I can recreate it easily. And so they have a way to do that. And I've clicked through this and I've had this snapshot and I've used that to build a new notebook. And here's the notebook that I created for serving. And now I have this serving notebook up and running. But what I'm going to do now is just the last part of the model, right, is the prediction phase. I'm going to the bottom where we were before, and I'm going to show some things I've added in here. So we remember we left off on the last where we did that print validation loss. That's what we were using to do the hyperparameter tuning. But now what I'm going to do in this particular notebook, which I'm using for serving, is I'm bringing in some Kale serving utilities. Now I could easily serve just a predictor pod using KF server equals serve model close parenthesis. But in this case, I have a preprocessor. So I'm going to have two pods that I'm going to deploy. One is going to pre-process the data, and the other is going to make a prediction against it. So that's why you have this additional syntax here. And the preprocessor also has a tokenizer. So those of you that like to use tokenizers, you'll have that capability as well. So I run this, right, particular, and what it does is Kale reads through all the code, it dumps it, and then it creates the pods to be able to, it writes all the YAML to create the pods to deploy those two pods, the preprocessor and the predictor pod. And that's what all this is coming back and is talking about. All this pink code here is talking about how it's getting this all ready to have this inference service ready. And now if I want to go in and look at this, right, I can click in here and I can look at the model that as it's being served. So before I do that, I've prepared some data, and I'm going to have this predictions data. And you can see I've already started to run some predictions through this, but I'm going to run some data into the model so we can see what it looks like in real time in the UI that you're using to model the monitor, to monitor the model that's in production. So now I'm clicking over from this right here into this model that I have running. And now you can see that there's a predictor pod that's been deployed, a transformer pod. I have internal and external URLs in order to send and use in my, if I'm integrating this with an application, these are the URLs that I'm going to use. I've got a status. I see some other things. There's a lot of detail that I can go into here at what the container serving. And then I have my model here is basically, this is the metrics tab. So you can see on both the predictor pod, I've got my total CPU utilization and my memory utilization. because I started to send some data to it, you can see these are spiking, my request volume by revision. And these are all the specs Grafana based that are coming basically for the predictor pod. I also have for my transformer pod. And again, you can see these things are starting to spike up because I was sending a lot of predictions into it. And if we went back here, you can see how some of these predictions are coming in here, and they're also showing up in these graphs as we're going through. So that's a nice feature. You also have logs. So if you want to do debugging, you've got logs on the predictor pod and the transformer pod that come out that you can see what's going on. And of course, all this YAML that was automatically, this is how this was all deployed in KF serving or KServe, sorry. You can see this YAML here, and this YAML isn't it's not a whole lot. I think it's 150, or maybe it's a little bit more than that. But if I look at like the spec for the predictor pod, right? It's TensorFlow. I've got a container, KF serving container. How many CPUs? What's my memory? I mean, this is all pretty human readable. What's my storage URI? So look, that's kind of the demo that I wanted to show you, back to Kubeflow. Hopefully this gives you kind of a good view of many of the components. This was just to give you a flavor of what the kind of the UI looks like, and an end-to-end going from building a model in a notebook and then building a pipeline and then using it in prediction. Hopefully that gave you a little flavor of it. And so I welcome everyone into the Kubeflow community, right? There's a Slack channel that you can join, easy to find, or attend a Kubeflow community Tuesday meeting. Every Tuesday we have meetings. They're in the morning and then in the evening. And they alternate depending on the week. And then there's a Kubeflow Summit coming up. Usually these are held at Google in Sunnyvale. I don't know this year if that'll happen, but we're still looking for the final location. And we have the user survey. You can go in and see what other people and dive into the survey. And I really think the best way to learn Kubeflow is just get your hands on. A lot of the tutorials that I've shown you here, they take about an hour to run. Literally maybe an hour to an hour and 15 minutes from the time that you go in and start and find exactly where to start from, let's say on MiniKF or Kubeflow as a service. From the time that you say go, it provisions everything, and then you're into starting to go through and run through these end-to-end workflows. And as you can see, there's a lot of great people and a lot of great organizations in the Kubeflow community, and I really welcome you to come in and challenge yourself against some of the best in the world, solving many of the world's best problems. So that's basically it, Jordan. Hopefully it was a little longer. I told you it was going to be 35 minutes. I went a little bit longer, but hopefully not too long.
No, that's absolutely fine. Thank you so much for putting the presentation together and giving such a great demo. We do have a couple of questions just come in last minute. Well, actually, just a couple of comments and then a couple of questions. So firstly, from Jerome, this is very impressive, Josh. Thank you for doing this and showing the demo. So thank you for that. Another person, anonymous, impressive tool. And then another question, how does this capture model artifacts?
Yeah, so if you look here, I didn't get to this part, but there is a tab here that has the artifacts. So all the runs that are going on in the pipelines, you'll see that there are artifacts that are being captured for each of the runs. And if you go into some of these, you actually get a lot of good detail, is like what the URI that was used and what are all the properties, as well as you can see this lineage explorer, where you can see where the model training and, what this, like in this case, we're using Ericto, so they're snapshotting each of these steps as you go along the way. So you're able to see a lot of the details, right? In addition to the artifact space here, you also have an execution space. So everything that's run, you can see as it's being run. Again, you can dive into here and see the runs and dive into any of these steps. And there's a lot of detail that come across all the way through the ML metadata and the pods, the logs, hopefully all these come up and you don't see any errors. But I mean, the errors are actually good, and it shows that everything is working as it should. That, you know, if something comes up and isn't what it should be, at least you've got a way to go and debug it, which is really kind of the hard part because there's so many moving pieces. Hopefully that helped answer the question.
Perfect. And then just a couple more. Does it caches steps such as data pre-processing so that it is not repeated? Yeah,
that's actually shown here. So, and it's a great question, especially when you're talking about CAT-TIB and the hyperparameter tuning, where you're running the same pipeline over and over, and it's the same inputs and the same outputs. Why run it again? You cache it. So yes, we do support, Kubeflow Pipelines does support caching of steps, saves a lot of resource infrastructure spend as well as time. And even in the latest version, Kubeflow 1.5.1 that just came out, we fixed some of the cert manager requirements. So you'll see that if you go to the Kubeflow blog post, which is blog.kubeflow.org, you'll see that we just came out with some fixes inside of even AWS that had a very strict requirement on how they deal with caching and how they need the cert manager to work. So we continue to improve upon that, but caching is supported even with very strict requirements around the certificate manager.
Perfect. And then we've got one final one. How is this related to TFX pipelines? TFX uses Kubeflow as orchestration, just like Airflow and Apache Beam.
Yeah, so TFX is a great project and provides great modules or components that can run in TFX separately, or they can run in Kubeflow. And what's nice about this is that a lot of the work they've done either in estimators or data validators or natural language processing, other types of things can be automatically used from the TFX libraries. And if you go through some of the tutorials, especially the ones on GCP, you'll see that you can use those tools, those pre-processed components in your pipeline. So you don't have to write them. They've all been tuned, right? And literally millions or more, tens of millions of dollars have been used to make those components work as effectively as possible. And so you can use TFX inside of Kubeflow, all those components. Now, Kubeflow has its own pipeline, but those components are transferable right into the Kubeflow pipeline component. And I think Kubeflow, in a lot of ways, because we have the hyperparameter tuning, because we have easy access into TensorBoard, because we have the portability between different environments, gives some advantages, especially to people who might need to use multi-cloud or just may want to have a little more control and not be of their ML platform environment and not be tied to like a SageMaker or a Vertex or one of those offers, which are very good offers. They're just a little different, and some people just want more control of their ML platform. So that's where Kubeflow, I think, provides that open source alternative.
Perfect. Well, that's the end of the questions. So yeah, thanks again, Josh, for putting together that presentation and great demo. I'm sure from the comments at the end and the questions that came in, everyone took something away from that, whether they're an avid user of Kubeflow or new to it. So thank you so much.
Yeah, appreciate the time, and everybody that's here. I'm on LinkedIn. Definitely like to connect with people. Please feel free to ask me questions or you see stuff. We tend to post a lot on LinkedIn, but I do, if you're interested in ML ops, if you're interested in something that I think has a lot of legs going forward, this deployment pattern, this technology, I think allows you not just to learn a lot of technology, but to meet a lot of people that kind of fit in that same space. It's a great networking, just like you've done here, Jordan, with the work that you've done and building a community. I really like it and want to support you. So thank you.
No, thank you so much. Really appreciate it. And everyone that attended today, thank you so much for your time as well, for the questions and the comments as well. I hope you took something away from today. And if you enjoyed this webinar, please do follow our LinkedIn page, the live series and Amicus Recruitment. And if you want to watch previous webinars that we've hosted, please do follow us on our YouTube channel, which is Amicus Recruitment. But yeah, again, Josh, thank you so much for your time today and for putting together that talk. Hope it's not too rainy in Dallas, or whether it's eased up a bit for you. But yeah, good luck with the big release for everyone, and yeah, I look forward to having you back on board when there's future releases.
Thank you guys, and have a good week. See
Perfect.
you later.
Cheers, Josh.
Bye.
Bye, everyone.